Hello, I'm Jordan Thurgood, the New Ventures Manager for Monash University, based out of Melbourne in Australia. And I'm delighted to introduce you today to Nextaero. One of the reasons that we've nominated Nextaero to be at the Falling Walls Ventures conference is the founding team, in particular their ambition and their drive. Their ambition to do something which is extremely difficult, their ambition to do something which hasn't been done before, and their ambition to reshape the aerospace and rocketry industries of the future. One small point I would like to note for everybody before Graham comes on stage is he submitted his thesis 2 days ago before jumping on a plane and flying all the way around the world. So if you have a question for him later, you'll probably find him relaxing by the bar. By the end of the talk today, I'm sure you'll agree with me that for Nextaero, the sky isn't the limit. Please welcome Graham Bell of Nextaero.
Breaking the wall of space commercialization. Graham Bell, Nextaero.
Thank you very much. So it seems that space does capture our imagination, as from our CTO mentioning space. So whether it's spacewalks, rockets or satellites, it really seems to be quite captivating for people. I've thought about this a lot, and one of the reasons I think is that it really provides a pretty inspirational sense of the future. It inspires cooperation and teamwork, and also a sense of prosperity. The future of space really has to be commercial, in my opinion. The National Space Agency model that we've gone through the past has gotten us to some point, but we now rely space commercialization to take us to the future. There's one industry in the realm of space that has taken us further, that is satellites. That's a $15 billion industry which provides observational data to governments, companies, and agencies around the world. Unfortunately, other industries, like for example bespoke manufacturing in space, haven't kicked off yet. There's a couple of reasons why this is. Access to space is a major limitation. The frequency with which we're able to launch rockets into orbit, and also the cost. Our company, Nextaero, is working on just the access to space challenge. Rocket manufacturers, there are significant improvements that can be made for rocket manufacturers in terms of efficiency. Rocket designers, unfortunately, have their hands tied. Companies right now develop the entire rocket, the entire launch vehicle, each individual component. There are significant improvements that can be made, and there's a lot of performance, revenue, and cost savings that are kind of left on the table. Nextaero manufactures just the rocket engine. So we're working on a different type of engine, which essentially takes the bell shape that you've seen on a normal rocket and flips that inside out. So the engine's essentially turned inside out. What we have is now a spike, and the gas coming out, or the flame coming out, is now expanded. The spike allows the rocket, as it goes through the atmosphere, to more efficiently expand the plume that comes out, and this gives this engine about 25 to 35% extra payload performance to get to space. That kind of sounds meh, but actually single-digit performance improvements are important for this particular industry. So one of the major challenges for manufacturing these, why hasn't this engine been developed before? One of the major manufacturing challenges is that the engine's inside out. We've got a lot of small features and small cooling channels on the inside which need to be manufactured. We use metal 3D printing to actually manufacture all the complex shapes. You can't manufacture this particular engine, I'll show you the inside here, traditionally using traditional mills, drills, casting methods. We actually need 3D printing. Not only can this engine not be manufactured traditionally, it's actually pushing the limits of what we can do with design. Humans can't actually design some of the shapes. We're using genetic algorithms to design and develop the individual thermodynamics, the structural dynamics, and the metallurgy of the engine to bring it all together. The future of this industry, in order to bring launching different industries into space, for example, bespoke manufacturing of biotechnology and also glass manufacturing for optical uses in space, requires really frequent launches that are done at a really short amount of time. So actually bringing reusability and reliability into a product is a big element. And so through 3D printing, we're actually reducing the number of parts in the engine so that we reduce the risk, weight, and cost. Aviation industry has also inspired us to learn how to actually develop a really capital-intensive transportation industry. And so we're actually using a lot of lessons learned from aviation. Some of those are, for example, that jet engines aren't actually sold. They're rented to airlines. And so an airline will actually rent an engine, sell the seats on the plane, and pay for the engine per passenger mile. this allows the engine manufacturers to take data from the particular flight and switch the engines over between. They're actually cycled between all the different planes as a function of time. And this is what we're looking at with our engine as well. So with that, I'll say thank you very much, and I'm happy to take your questions.